April 8, 1968, London Heathrow Airport. A Boeing 707 was preparing for departure to Sydney, Australia, operating as BOAC Flight 712, British Overseas Airways Corporation. The planned route included stopovers in Zurich, Tel Aviv, Tehran, Mumbai, Singapore, and Perth. Depending on weather conditions and potential delays along the way, the total flight duration was expected to be around 40 hours. For this flight, a total of 116 passengers had completed boarding at Heathrow, most of whom were British and Australian nationals. The crew consisted of 11 members, 5 in the cockpit and 6 in the cabin. The captain, 47-year-old Charles Taylor, had accumulated nearly 15,000 flight hours, including approximately 1,500 hours on the Boeing 707, meaning he had more time on that aircraft type than the captain himself. Also in the cockpit were a flight engineer, a second officer, and a check captain, or supervising captain.
The Boeing 707 was a truly revolutionary aircraft that transformed the aviation industry. Its success was built upon decades of technological innovation. Although it was not the first jet-powered airliner in the world, it became the most iconic, ushering in the true jet age of commercial aviation. The Boeing 707 was equipped with 4 Pratt & Whitney JT3D turbojet engines, striking a well-balanced compromise between speed, comfort, range, and performance. It was better suited for long-haul flights than any aircraft that came before it, and it reshaped the entire airline industry. At exactly 4 p.m. local time, passengers began boarding, while the flight crew carried out pre-departure preparations. At 4:15 p.m., Flight 712 requested pushback from the gate. Ground control cleared the flight to taxi toward runway 28 left for departure. After receiving takeoff clearance, the captain released the brakes and advanced the throttles. Flight 712 accelerated down runway 28L and lifted off smoothly. It was a clean, uneventful takeoff, and no one suspected anything was wrong. Shortly afterward, the captain issued the command to retract the landing gear.
A few seconds later, the pilots would reduce engine power to comply with Heathrow's noise abatement procedures. Typically, this procedure is carried out about 1 minute after takeoff. But only 20 seconds after liftoff, a loud explosion echoed through the aircraft, shaking the entire cockpit, cabin crew, and passengers. No one knew exactly what had happened. The plane began to shake violently and drop slightly. Passengers seated on the left side near the wing were the first to witness a terrifying scene. The wing was on fire. Hearing the passengers panic, Chief Purser Neville Davis Gordon immediately got up and began walking toward the front of the cabin. Dr. Richard Hyman, a passenger seated by the window, took out his camera and captured a photo of the blazing wing. Inside the cockpit, there was complete confusion. The 5 crew members were trying to figure out what exactly had happened. At the time, the aircraft was not equipped with a cockpit voice recorder, as it was not yet mandatory in 1968. That regulation would only come into effect several years later. Therefore, we cannot know for certain how the crew responded in those critical initial moments.
This type of alarm has a manual shut-off switch. Once the crew confirms an emergency situation, they can manually silence it. As a result, the captain, check captain, and first officer all reached out to turn it off. According to the report, under such circumstances, another alarm that should have been triggered on the aircraft was the fire warning bell. If engine number 2 was on fire, the fire bell and its associated warning light should have been activated simultaneously. However, an unexpected event occurred. While the first officer was silencing the landing gear warning, he accidentally and unintentionally pressed the fire bell mute switch as well. As a result, the fire bell for engine number 2 never sounded. This means that during the initial critical moments, the crew may have had no awareness that the aircraft had already caught fire. If they also failed to notice the fire warning light, then it is likely they truly did not realize the seriousness of the situation at the time.
This type of alarm has a manual shutoff switch. Once the crew confirms an emergency situation, it can be manually silenced. As a result, the captain, the check captain, and the first officer all reached out to turn it off. According to the official report, another alarm that should have sounded under these circumstances was the fire warning bell. If engine number 2 had caught fire, the fire bell, along with the corresponding warning light, should have been triggered simultaneously. However, an unexpected incident occurred. While the first officer was turning off the landing gear warning, he accidentally also pressed the fire bell silent switch. As a result, the fire bell for engine number 2 did not sound. This means that during those initial critical seconds, the flight crew may have had no idea that the aircraft was already on fire. If they also failed to notice the fire warning light, then it's likely they truly did not realize the severity of the situation at that time.
However, the truth quickly came to light. The check captain, who was seated by the window, glanced outside and suddenly saw the left wing engulfed in flames. He shouted, "The wing is on fire," and strongly urged the crew to send an emergency distress call and return for an immediate landing. Moments later, the first officer radioed air traffic control, issuing the emergency call, "Mayday, Mayday, Mayday." Almost simultaneously, the captain finally noticed the fire warning light for engine number 2, and immediately ordered the crew to initiate the engine fire procedure. It was at this point that a combination of human error and chaotic circumstances led to a critical misjudgment and delay. When the captain initially ordered the execution of the engine failure emergency procedure, the responsibility for carrying it out naturally fell on the flight engineer. This procedure involves a series of memorized steps that all crew members are required to know by heart during routine training. These actions must be executed immediately and efficiently, because in emergencies like this, every second counts. As per standard procedure, the flight engineer was expected to begin the checklist immediately upon the captain's command. Looking at the main control panel, the flight engineer was supposed to pull the fire shutoff handle, but he hesitated. He was fully aware that the procedure they were following was not the fire checklist, but the engine failure checklist. And under standard engine failure procedures, pulling the fire handle is not included. Moreover, they had not heard the fire warning bell.
This may have further contributed to misjudgment and hesitation. Next, let's take a look at the engine fire emergency procedure. This procedure is divided into 2 stages. The first stage consists of memory items, similar to the engine failure checklist, which the crew must execute immediately. However, the critical difference between the fire and failure procedures is that the fire checklist explicitly includes one key step: pulling the fire shutoff handle. Pulling this handle triggers several essential actions. It activates the fire suppression system. It shuts off the fuel supply to the affected engine. It disconnects the engine from the electrical generator system. According to the post-accident investigation and analysis, when the captain finally ordered the execution of the fire procedure, the flight engineer began carrying it out, but omitted this critical step. This meant the fuel shutoff valve was never closed. Fuel continued to flow into the burning engine and wing structure, causing the fire to intensify rapidly. This serious operational omission was the result of multiple contributing factors: procedural confusion, lack of clear warning signals, extreme operational pressure,
over-reliance on memory, and fragmentation of crew responsibilities. As a result, this key step was missed. Despite the aircraft's deteriorating condition, the captain maintained control of the plane. He began initiating a left turn, intending to return to the airport. On the ground at the control tower, air traffic controllers witnessed from a distance the disintegration of engine number 2 and the smoke trailing from the aircraft. One controller immediately pressed the emergency alert button, notifying all emergency services to stand by. The controller then cleared the airspace and began using radio communication to instruct all aircraft approaching Heathrow Airport to enter a holding pattern. At first, the controller assumed that Flight 712 would choose to return to runway 28, the same runway used for departure. However, considering the extent of the aircraft's damage and the operational conditions at the airport, the crew ultimately decided to land on runway 05R for the emergency landing. This was an extremely critical decision. Compared to the other runways, runway 05R offered a more direct, shorter, and safer approach path, gaining precious time for what would be a race against the clock. At this point, Flight 712 was performing a sharp left-hand turn, flying at an altitude of 3,000 feet and a speed of approximately 225 knots.
Despite the aircraft's deteriorating condition, the captain maintained control of the plane. He began initiating a left turn, intending to return to the airport. On the ground, at the control tower, air traffic controllers witnessed from a distance the disintegration of engine number 2 and the smoke trailing from the aircraft. One controller immediately pressed the emergency alert button, notifying all emergency services to stand by. The controller then cleared the airspace and began using radio communication to instruct all aircraft approaching Heathrow Airport to enter a holding pattern. At first, the controller assumed that Flight 712 would choose to return to runway 28, the same runway used for departure. However, considering the extent of the aircraft's damage and the operational conditions at the airport, the crew ultimately decided to land on runway 05R for the emergency landing. This was an extremely critical decision. Compared to the other runways, runway 05R offered a more direct, shorter, and safer approach path, gaining precious time for what would be a race against the clock. At this point, Flight 712 was performing a sharp left-hand turn, flying at an altitude of 3,000 feet and a speed of approximately 225 knots.
In the cockpit, the captain was doing his best to line up the heavily damaged aircraft with runway 05R. However, more problems quickly emerged. The captain realized the aircraft was too high, too fast, and runway 05R was not one of Heathrow's main runways. It lacked an Instrument Landing System, ILS. And with the aircraft in its current state, there was no time left for another approach. This would be the crew's only chance. The lives of everyone on board depended on the captain's handling of this final approach. Up to this point, despite the aircraft being on fire and having lost one engine, the captain had managed to maintain basic control. But after the engine detached, the gaping hole left in the wing began leaking hydraulic fluid, gradually causing flight control systems to degrade. When the captain ordered the flaps to be extended to 50 degrees, the flaps jammed, unable to reach full deployment. Just seconds before landing, the Czech captain used the cabin PA system to inform passengers to brace for an emergency landing. BOAC Flight 712, just over 3 minutes after departing Heathrow, was brought down safely by the captain, drawing on his thousands of hours of flying experience. The landing was so precise, it was later described as textbook perfect. However, although the aircraft had successfully landed, the crisis was far from over. When the Boeing 707 finally came to a stop, its wing was still burning. Emergency responders began arriving on the scene. Firefighters from a secondary fire station drove their fire truck onto the runway and positioned themselves behind the aircraft. However, fire crews from the main fire station had not yet arrived. Inside the cockpit, the pilots shifted their focus to shutting down the aircraft systems. Fuel was still flowing through the aircraft, and the pumps, electrical systems, and hydraulics were all still powered.
The flight engineer quickly switched off the necessary controls, shutting down the engines and cutting auxiliary power. The captain called out to initiate the fire suppression procedure for the remaining engines, even though it was doubtful the aircraft would hold together long enough to complete it. Inside the cabin, passengers had already begun evacuating through the upper right side exits. As the evacuation began, the cabin crew successfully opened the left front passenger door and the right front service door. The evacuation slide on the right side deployed normally, but there were problems inflating the left side slide. The pull cord snapped immediately when the crew attempted to activate it.
It was later determined that the inflation mechanism inside the slide may have been damaged due to wear and tear from multiple flights, causing it to fail to inflate properly. Meanwhile, in the economy cabin, 2 flight attendants checked the situation outside through the left rear passenger door. The scene was extremely dangerous. The burning wing was just meters away, and flames from leaking fuel were scattered beneath it. The crew decided to close the door and instead opened the right rear service door. Shortly after the evacuation had begun, the main fuel tank in the left wing suddenly exploded, sending a massive fireball into the air. Thick black smoke rose skyward, blanketing Heathrow Airport. This was only one of several explosions that occurred, and at that moment there were still 100 passengers inside the cabin.
The firefighters who arrived on scene were overwhelmed by what they saw. The satellite fire station had limited equipment, only a few foam trucks and a single water hose. The main fire unit had still not arrived. The explosion caused the entire aircraft to shake violently, further compromising the airframe structure. Toxic black smoke poured into the cabin. The floor began to deform and shake, no longer structurally stable. Panicked passengers pushed forward in desperation. Some were knocked to the ground, making them even more vulnerable to being trampled, including elderly and mobility-impaired passengers. In the cockpit, the captain realized there was no time left. He abandoned his flight duties and issued a final order, in other words, to abandon the aircraft. All 5 cockpit crew members rose from their seats and moved into the cabin to assist the flight attendants. When they opened the cockpit door, they were met with thick, choking black smoke. They could no longer even see the other end of the cabin. Cabin crew were pushing back terrified passengers, urging them to evacuate as quickly as possible. The situation was rapidly deteriorating. If they were lucky, they had at most about 1 minute to get everyone out.
After the majority of passengers had evacuated the aircraft, the crew members also began to leave. 3 of the flight crew exited by sliding down ropes from the cockpit windows. On the ground, the crew, firefighters, and airport staff began counting survivors. It was discovered that 5 people were still missing. Their bodies were later found scattered near the rear of the cabin, among the charred wreckage of the aircraft. Among them was a cabin crew member. In less than 10 minutes, Flight 712 had been reduced to a burning wreck. The investigation report highlighted deficiencies in Heathrow Airport's emergency response, with poor communication cited as a key reason for the delayed reaction. From here, the central question became, what caused the initial failure of engine number 2? The failed engine was recovered from a gravel pit near Thorpe, and investigators also found additional debris scattered across the area over which the aircraft had flown, including internal components. Analysis of these fragments revealed classic signs of fatigue fracture, traced back to the number 5 low-pressure compressor disc. This was identified as the root cause. During flight, while the engine was running at high power, a fatigue crack rapidly propagated, eventually leading to catastrophic engine failure. The result was a release of enormous energy, causing what's known as an uncontained engine failure. The compressor section disintegrated, damaging other internal parts. Fragments punched through the engine casing, and the unpredictable direction of these fragments meant that one struck a critical fuel distribution line. This set off a chain of devastating consequences that ultimately led to the disaster of Flight 712.
However, the issue with this engine was even more complex. Engine number 2 had only been installed on the aircraft a few days before the accident. But it was not a brand new engine. It was originally manufactured by Rolls-Royce in 1961 and had operated normally during its initial years of service. In March 1965, after undergoing maintenance, pilots began to report problems with the engine, mainly excessive vibration. In May 1965, the engine was removed for inspection. Technicians discovered a fractured compressor fan blade, specifically in the 8th stage of the high-pressure compressor. After undergoing repairs, the engine was returned to service in October 1967. It was sent back to BOAC's maintenance facility, where, reportedly, the low-pressure compressor was removed and overhauled. The original number 5 low-pressure compressor disc was reinstalled in the same compressor unit. Crucially, during this entire process, no crack detection or fatigue testing methods were applied to the compressor disc. A month later, the engine underwent testing, and BOAC determined that it still exhibited excessive vibration. The engine failed the test. So then, the question arises, how did this engine end up being installed on the aircraft?
Although the engine had not passed BOAC's internal testing standards, the manufacturer, Rolls-Royce, held a different opinion. They applied different thresholds and criteria and considered the engine to have passed their tests. As a result, the UK Civil Aviation Authority, in this exceptional case, approved the use of the engine. The accident engine was then reinstalled on the Boeing 707, but shortly afterward it was removed again as the aircraft was undergoing scheduled engine maintenance. On April 5, 1968, the engine was installed in the number 2 engine position on the aircraft. 3 days later, the number 5 stage of the low-pressure compressor failed, resulting in an engine explosion. The final investigation report was released in April 1969. While the captain was praised for successfully landing the aircraft safely, the report also pointed to human error. The cause of the accident was cited as the failure to shut off the fuel distribution valve in time, which led to the number 2 engine catching fire after the number 5 low-pressure compressor disc failed. The investigation found that the emergency procedures for engine failure and fire were easily confused under high-pressure conditions. Investigators called on BOAC to thoroughly review their procedures and emphasize the importance of clear step-by-step execution and defined role responsibilities during emergency drills.
BOAC, British Overseas Airways Corporation, merged the two procedures into a single checklist and revised pilot training to ensure that all steps were read aloud during execution. At the same time, the emergency evacuation slides on the Boeing 707 were also criticized. The report called for further research into materials that could offer greater heat and fire resistance, and emphasized that evacuation slides must be capable of rapid deployment to ensure swift and safe evacuation. BOAC formally recognized the efforts of the captain of Flight 712 and most of his crew. In August 1969, Queen Elizabeth II awarded royal commendations to 1 air traffic controller and 2 cabin crew members. However, the flight crew received no official honors from the government or the Crown following the release of the final report. Barbara Jane Harrison, the flight attendant who lost her life in the accident, was posthumously awarded the George Cross in recognition of her extraordinary bravery.